My name is Christian Rasmussen. I'm an assistant professor here at the Natural History Museum of Denmark. I study biodiversity change in deep time. We have a new study which focuses on the Ordovician system, and the Ordovician is known as a period of extensive biodiversity change. We have a huge increase in biodiversity through the mid-Ordovician, and we have a large extinction event at the end of the Ordovician. The Ordovician is known as a period of raging high CO2 levels and extremely high sea level, and thus it is known to be a period of extensive super greenhouse conditions. We use two independent proxies. One is by use of fossils, in which we use the fossil groups trilobites and brachiopods. The other is we use stable isotope geochemistry to demonstrate fluctuations in oxygen and carbon isotopes. We show on a bed-by-bed scale how, in the orange color, how biodiversity is changing up through time. And at the same time, we see how, based on the oxygen isotopes, how it gets colder once we get up when biodiversity level is high. Thus, we can see here that we have the onset of a sudden cooling event just when we get the increase in biodiversity. Also, we show with the red line here that sea level is falling through the same interval as we see based on the isotopes that the temperature is dropping. Now, we would expect actually the temperature to increase because the area that we have done our study on is actually moving towards the equator in this time period we are studying. But in fact, we see the opposite. And thus, the 5-degree temperature estimate that we come up with is actually a minimum estimate. So this is basically a simplified hypothetical scenario of what it could have looked like, showing that in the late Cambrian we only had ocean surface, warm ocean surface currents, whereas in the Ordovician we actually get a deep water thermohaline circulation going with upwelling zones and warm surface currents. So much more like we see today. The short-lived ice age towards the end of the Ordovician, which has perplexed science until recent years, we can now demonstrate that there's no longer just a short-lived ice age, but in fact there's a prolonged cooling interval of at least 30-40 million years. And thus we can't believe that CO2 levels were as high as has been estimated previously.